Hello everyone, Gaza Mutkarsh, and I welcome you all to the session on managing list, dictionaries and sets. So guys, let's have a look at the agenda for this session. So previously, till the previous session, we have discussed list and list properties, list comprehension, dictionary and its properties, and even the nested data structure. So following the same topic in this module, we shall be discussing tuple and its properties, the different tuple functions that we have. Then we'll proceed to set and the different properties and the characteristics of sets that we have in Python along with the different set functions. Then we'll also look at how to utilize tuple and sets in data processing. So guys, I'm switching to the Jupyter screen. So guys, let's start with tuples, right? So guys, when we talk about tuples, right? So tuple is an ordered data type, as in the elements are comma separated in tuple. It is an ordered data type where the elements are comma separated and they are stored in round brackets. Alright, so the elements in tuple maintain their order and this order is preserved throughout the tuple's, let's say, lifetime. So their tuples are immutable, means once they cannot be changed. Simply put, immutable implies that they cannot be changed. So once a tuple is created, its content can't be modified. This means we cannot add, remove or change the elements within a tuple. Next, tuples are heterogeneous, as in tuples can store elements of different data types, such as integers, strings, floats, and even other tuples, right? We can store the elements of different data types. Tuples are indexed as well. So elements in a tuple can be accessed using their index starting from 0 for the first element. So the indexing and slicing properties that we have seen in list, they do follow. They are followed in tuples as well. And tuples can contain duplicate values. So tuple, they do have a fixed size. The size of tuple is fixed at the creation and cannot be changed. It can be overwritten, but it cannot be changed. Tuples, let's say, are iterable. We can iterate over the tuples based on either indexes or based on elements. So tuple can be iterated over, let's say, using loops, allowing sequential processing for each elements. Then it supports slicing as well. So tuple supports slicing, enabling the extraction of subsequences of elements. All right, so guys, these are the different properties of tuples that we have. Let's understand how to create an empty tuple. So for tuple creation, we have two different options. We can create empty tuples in these different ways. So over here, I'm writing tuple and then I'm writing type of T1. Next, over here, I'm writing T2 and then I'm writing type of T2. So guys, as you can see, these are two different approaches using which we can create empty tuple. Let's have a look at an example of tuple. Now in this example, I have demonstrated that I'm utilizing different elements and the elements belong to different data types. So when we have 10, 20, Python 4.5, 7.2 and welcome. So 10 and 20 are integers, Python is a string, 4.5 and 7.2 they are floats, and welcome happens to be again a string. So next, when I'm printing T1, this is what we have. Now how do I check the length? So each and every comma separated element contributes +1 to the length. And how do we know this is a tuple? Because the elements are comma separated and the elements are, let's say, represented in round brackets or parentheses. Now, what is the type of T1? So the type of T1 that we have over here is tuple. All right. The data type that we have over here is tuple. Next, let's have a look at, let's say, the different tuple functions that we have. So tuple only has, let's say, two different functions, namely count and index. So over here, I'm creating a tuple, maybe 10, 20, then some string, and then maybe 20 again. Then maybe, let's say, I'm passing 41, then I'm passing hello, then again I'm passing string, then maybe 20 again, and let's say 10, 15, some float value 7.8 and so on. Now if I wish to know, first let's understand the count function, right? So if you're talking about count function, let's see. If I print t2 dot count, I want to count what is the count of 20. How many times is it repeating? So okay, this I can pass comma. So 20 is repeating 3 times. I want to know how many times is 15 repeating. So 15 is getting repeated once. How many times is the element string getting repeated? So it is getting repeated twice. And then maybe I need to check for 10. How many times, let's say, do we get 10? How many times is 10 repeated? So 10 is repeated twice. All right. So guys, this is how we can utilize count. Now moving on to index. So I want to see index returns the index of first occurrence of the element in the left to right direction. So I want to know what is the index of maybe 41. So what is index of 41? 41 is present at index 4. Let's check 0, 1, 2, 3, 4. I need to know what is the index of maybe let's say 15. So 15 is present towards the last, right? So what is the index? The index is 9. But if I were to check the index of 20, so it will return the first index, that is 1. So 20 is present at index 1. And let's say for count, if I wish to count t2 dot count, I need to know what is the count of maybe 65. So if the element is not present, its count would be 0. So guys, this is how let's say we can perform these other two functions that we have in a tuple. Now we can also apply iteration and even proceed with indexing and slicing. So let's see these examples. So if we were to see different iterations in tuple, let's see. This is my tuple. So again, we have two approaches. Element wise iteration. So how do we proceed for I in T1? Maybe I can reduce the elements. So just 4 elements for the time being for I in T1, and then I can print I. So this is simply element wise iteration. We can also proceed with index wise iteration. All right, how do we proceed with index wise iteration? So this is index wise iteration. For I in range length of T1, and then I can print I T1 of I. So guys, as we can see, there are 4 elements, index ranging from 0, 1, 2, 3. So I and T1 of I. So over here I'm having 10, 20, Python and 4.5. So guys, this is what we have, right? This is how we can, let's say, proceed with element wise and index wise iteration. Now for the same tuple, I can also implement indexing and slicing. If I wish to know what is the element at index 2, I can write like this: the element at index minus 1. So see, it is Python and 4.5. What is the element at index 0? So it is 10. So this is how we can proceed with indexing. And as far as let's say slicing is concerned, for the same T1, if I write 5, it means what is my start? Start is 0, the end is 5, and what is the step size? The step size is +1. So guys, this is what we are getting. Then over here, if I write T1, maybe let's say 3 colon, then what is my start? The start is 3, the end that we have is the end is unknown, and what is my step size? The step size that we are getting over here is +1. Step size is +1, so over here I'm getting 4.5. Why 4.5? Because this is the last element. Maybe if we start from 2, so we'll get Python and 4.5. So guys, this is how we can perform indexing and slicing. If you want to see negative indexing and slicing, that can be done. So maybe -1 all the way up to the end with a step size of -2. So we'll get, first of all, we'll be getting 4.5, then we'll get 20. All right, so what is the start? The start is -1, the end is not defined, and what is my step size? The step size is -2. So starting from index -1, which is the element is 4.5, we have to go all the way to the extreme left, and what is the step size that we have applied over here? That is -2. So 4.5 all the way up to minus let's say 20. -2, so that goes up to 20. So this is how we can perform indexing and slicing in tuples. All right, now let's see what are the use cases of tuples in data processing. It is, let's say, used for storing fixed records, for example, representing of raw data from database. We used to store those values in tuples, let's say, for the data that we are absolutely certain that they are not going to change. All right, means we can, let's say, not going to change, as in suppose we do have employees working in an organization, right? Their employee ID is not going to get changed. Are you getting this? So these are the kinds of data for which we can store data in form of database. Let's say for returning multiple values from a function, we can utilize tuple. So I'll show you an example. So maybe let's say perform, or let's say compute operations. So this is an example of returning multiple values from the tuple. So the output is going to be a tuple, right? So based on x and y, I want to perform multiple operations. So add would be x plus y, then product would be x into y. All right, and difference would be x minus y. Now because I need to return multiple values, I'm passing add, product and difference. As we can see, the function is returning multiple values, so we need to store the result. Alright, so over here I'm writing xy sum, then I'm writing xy prod, and next I'm writing xy difference, and I'm calling the function compute operations, and then I'm passing maybe, let's say, 8 and 3. So now if I print these values, so the sum is xy sum, then the product is xy product, and the difference is xy difference. This is product and this is the difference. So guys, if you observe, the sum over here is 11, the product is 24 for 8 and 3, and the difference is 5. So clearly the function returns multiple values and the output is returned in form of a tuple. So how do we check this, that the output is tuple? So if I just call this, please observe the output that we are obtaining over here is a tuple. Now it can be used as keys in the dictionary. So I'll show you this example as well. Let's say tuple as keys in dictionary. So maybe I'm creating a dictionary, then I'm utilizing the tuple. All right, maybe name Ankit. For this name Ankit, let's say the skills are C++, Python, and maybe ML. Okay, instead of C++, I'm writing maybe Power BI, Python, and ML. These are the skills. For another employee, after Ankit, maybe over here I'm passing. Okay, this is a tuple, right? So for maybe Ankit and Ayush, these are the skills. For the next, let's say, tuple of employees, maybe over here I can pass Ayushi and Pankaj. The skills are Excel, Pandas, and maybe AWS. Alright, so now if I print the D1, see, we have used tuple as dictionary keys. Over here I have to pass comma. And as you can see, we have been effectively utilizing tuple as the dictionary keys, right? Now guys, moving forward, let's proceed to sets. So let's understand the different set properties. So set is an unordered collection of elements where we cannot have any duplicates, and the elements are stored in curly brackets and they are comma separated. So set is unordered. Elements in the set do not have a specific order. They can be displayed in any order because in the backend they are hashable types. Now all the elements in the set would be unique. So sets do not allow duplicate values. Sets are mutable, implying that they can be modified after creation. Elements can be added or removed, or existing element can be changed. We can have heterogeneous elements. Sets can contain elements of different data types. Sets are iterable. Sets can be iterated using loops. Efficient member testing. Checking if an element exists in set is highly efficient. So to check if an element exists or not, we typically utilize sets. Now the sets do follow the different mathematical set operations such as union, intersection, difference, symmetric difference, and so on. Now sets do not offer any indexing or slicing, reason being that they are unordered, right? So elements in the set cannot be accessed using indexing. Now set elements are hashable data types. So the elements must be hashable, as in the elements in the set must be immutable. All right, and we have to pass dynamic size. Sets can grow or shrink in size as elements are added or removed because they are mutable. So guys, let's understand these examples. So how do we create an empty set? Empty set can be created like this. S1 is equal to set. So we do have only one option. Now if we consider that because sets are enclosed in curly bracket, can we create a set using empty curly bracket? Absolutely not. That would end up creating a dictionary. See, empty curly brackets would end up creating a dictionary, which we have already discussed in the previous sessions, right? Now, sets can't have duplicate elements. Let's check this. Now, observe this. In the set S1, I'm passing 10, Python 14, 7, 17, 5.6, Hello 14, 17, 25, and Google. Clearly, we do have multiple duplicates, right? But when I'm printing, First observe that the order is changed. So why the order is changed? Because it is unordered. Next, let's say no duplicates. Do we get to see any duplicates? No, we have none. We have Python 5.67, Google 10, 14, 17, 25 and hello. So we don't get to see any duplicates over here, right? Now, the fundamental purpose of sets in data preprocessing is removing duplicates from a list or tuple. So over here, I do have a list I want to get rid of, let's say duplicate. So first I'm converting it to set. So observe this. Now all the duplicates are gone. Now we have 36, 10, 20, 24, 25, 28 and 30 without any duplicates. Now if I were to convert it to list again, so now as we can see, the original data type was list. We have let's say the objective was to get rid of all the duplicates. Now we are left with no duplicates. Now we can perform indexing, slicing, sorting on this list as well. Now let's proceed with the different list functions. So we do have functions like union, intersection and difference. Let's understand them one by one. So S1, S2, S3, right? So these are the different elements in the set. Now in S4, maybe over here I'm writing union. So union is S1 dot union. Maybe I'm writing S1, S2 union, right? S1 dot S2 union. So what is union going to represent? Union is simply going to combine all the elements from set 1 and set 2, and I'm storing the result in S1, S2 union. Please observe. So I'm having, let's say 1, 2, 4, 5, 6, 7, 8, 9, 10, and then what is the element which is captured from here? That is 15. Alright, the element 15 is also captured. Maybe I can add another element. So maybe I'm going to add, let's say 8. 8 is also present. So let's add 3. Now as we can see, I get to see all the elements, right? So union, basically what is union doing? Combines all the elements of multiple sets, all right, without duplicates. Without any duplicates, all the elements are getting combined. Now what about intersection? S1, S2 intersection. So I can write S1 dot intersection S2. So now if I print this, intersection means it will generate the common records. It returns the common records from both the sets. All right, let's see this. So what are common elements in these two sets? The common elements that we have over here are 10, 4 and 7, right? Please observe the three common elements that we have in this set are 10, 4 and 7. And then if I were to show you the difference, okay, so this is S1 difference S2. S1 difference S2 means all the elements which are in S1 but not present in S2. So difference S2. So what is it going to return? Return all the elements, let's say present in S1 which are not present in S2. All right, so now if I were to print this, I'm getting 135. Please observe 1, 3 and I'm assuming 15. Yes, 1, 3 and 15, they are present in S1 but they are not present in S2. Likewise, if I perform the reverse operation, S2 dot difference S1. So S2 dot difference S1, what would be the output? Returns all the elements present in S2 which are not present in S1. All right, so this is S2 dot difference S1. So observe this. So we have 2, then we have, let's say 6, then we have 8, 9, right? 2, 5, 6, 8, 9. These are the elements which are present in S2, not present in S3. So guys, this is how we can utilize, let's say union, intersection and even difference. The next function that we have is update. Update is used to, let's say, update union of one set with another set. So these are the three sets that we have, or let's consider the two sets that we have. So it is same as the union. It's just that the original set will be updated in the union or intersection over here, and even the difference. The original sets do not get changed. I'll print the original sets after these operations. please see S1 and S2. There is no modification as far as the original sets are concerned. They remain as it is, right? But when we perform update, the original sets do get changed. So we do have options of updating like intersection update, let's say update, difference update. All these options are available, but currently I'm just showing you an example of normal union update. So this is before update, and when I'm applying s1.update to s1.update s2, so all the elements of s1 and s2 would be clubbed in the set s1. And because we cannot have any duplicates, so all the duplicates would be removed as well. So guys, if you observe over here, this is the set after update. And what is the set that has been updated? It is the set S1. There is no corresponding change in the set S2. If you observe, we have 2, 4, 5, 6, 7, 8, 9, 10. We still have 2, 4, 5, 6, 7, 8, 9, 10. But the S1 has been updated. 1, 4, 7, 15, 10 now we have, besides 1, 4, 7, 15 and 10. We do get to see 2, 5, 6, 8, 9, right? Where are they coming from? They are coming from S2. So guys, this is how we can perform update. Next, we have couple of functions such as clear and remove. So clear is simply meant to empty the set. Remove is used to remove the elements from the set. So if you observe this, this is S4, and then I'm printing S4, then S4.remove 18. So 18 would be removed. All right. Then we have remove 25. So after see 18 being removed, we do have 25. Now I'm removing 25. Now if I were to clear the set, so it simply empties the entire set. Now we have discussed and implemented the clear function in both list and even dictionary, but we don't have this clear function in tuple because tuple is immutable. Next, we have a very important function in set which is referred to as add. So add is simply used to add new element to the set. So suppose I'm having a set 10, 20, Python, 15, 25 and welcome, right? So based on this set, first of all I'm printing s5, then s5.add SQL. Over here I'm writing s5.add SQL, and as we can see, SQL is added over here, right? SQL is added over here. Now where it will be added, we cannot control this. Let's say elements in the set can be added anywhere. We do not and we cannot control this. It can be added anywhere. Next I'm adding 78. Where is 78 getting added? Over here. Suppose if I were to add maybe, let's say Python. So where is Python added? Okay, Python is already there. Maybe I wish to add, let's say, functions. So where are they added? They're added at the end. Now if I add maybe, let's say, something like this, 7.4. So 7.4 is added over here. All right. So clearly we can see there is no particular order being followed. It can be added in any order. Now, what are the different use cases of sets in data processing? Removing duplicates from a data set. We have just seen this. I'll replicate the same process again. So we do have a list of numbers. I want to get rid of duplicates, right? So this is the first application. This is how we can get rid of duplicates. We have seen this. Second operation is fast membership test, checking if an item exists or not. So suppose we have, let's say, employee IDs. We have IDs like 201 and then 205, 207, okay, 207, then we have 210, then maybe 215, all right, and then we have 220. Maybe we have these employees, and maybe a couple of more, 224, 227, 232, maybe we have 216. These are the employee IDs that we have. Now I want to check if a couple of employee IDs do exist or not. So over here I'll be converting it to, because we are talking about fast membership test, so I need to convert the IDs into sets. Set of employee IDs would be set of employee IDs, right? So I can print them. Now based on these sets, I want to check if the employee ID 201 is present in set employee IDs. Is it present? Yes. So these operations are fast. Now if I were to check if the employee ID may be 245 or let's say 221, is it present? No, it's not present. I can check for another ID. Maybe I wish to check it for let's say I want to check for maybe let's say 207. Is it present in the set employee IDs? Yes, it is present. So this is what is referred to as fast membership tests when conducted on sets. This operation is quite fast. The next, let's say, application of sets that we have for real-time data processing is set operations, namely union, intersection, difference. So which we have already discussed, right? So guys, this is what we have discussed as far as tuple and tuple functions are concerned. Then we have also discussed about set and set functions, right? And yeah, I think there's one thing left. Maybe we can see how to iterate over sets, right? Iteration on sets. Let's see this. So the procedure is simple. Now if I'm having a set, maybe 10, 20, 15, 7.8, and then maybe over here I'm having Python. So how do we iterate? Now, of course, we don't have the option to iterate element wise, index wise, right? That option is not available. So I can simply say for I in S1 print I. So the elements would be displayed. Now, in which order, that we cannot comment upon. Why? The reason being sets are unordered. So whenever we are discussing about sets, be mindful of the fact that sets are unordered, right? So this is how we can iterate on sets. Can we perform indexing, slicing? No. Not allowed on sets. I can show you an example. Let's see for the same data. For the same data, this S1. Now, if I were to write S10, I'll get error. I'm getting an error, right? See. Now, can I perform S1 maybe -3? S1 -3, again an error. And if I were to perform S1, then maybe 2 all the way up to 4. So again, this would be an error. So no indexing and no slicing. So sets do not, let's say, allow indexing and slicing. So guys, that brings us to the end of this session. So I'm switching to the PPT. So guys, in this session, we have discussed, we have understood tuple and tuple operations. We have understood set operations in Python, and we have utilized, let's say, tuples and sets in data processing. Thank you.